class, right? Our minds do not see this as C-L-A-S-S unless your spelling teacher is asking you to spell it. Our minds perceive this as the word class. We take each of these individual elements and we put them together. Okay? So that's what we're talking about. This same concept can work in algebra. Take a bunch of things and put them together into one group. Look, here we have 2 quantities of y plus 8. Here we have 3 quantities of y plus 8. So if you just squint your eyes and think of these quantities as just x, we would have a total of how many quantities of y plus 8? 5. You see, 2 plus 3 is 5. So this is 5 quantities of y plus 8. To finish the simplification process, all we have to do is distribute. And so we will get 5y plus 40. So look at very little work here. Very, very little work. Even though we started with something that looked horrible, right, to begin with. If you apply that concept of grouping. So here we have some algebraic fractions being added together. The point we're trying to make to you is the denominators are the same. So you can think of them as just x. So this would be 4x, 4 over x, plus 3 over x, which would be 7 over x, right? All right, so just think of these as groups, and we'll end up with 7 over x, and x, of course, is 3x plus 1. So if you can think of this grouping concept, you can do these practically instantly in your head. Is something of very importance that I need to mention to you. Can you take 7 and divide it by 0? Is it possible in this world to divide by 0? No. Okay, that's an undefined process. So there is a value out here that x cannot equal because it will turn the whole denominator into 0. And this is very, very important. Okay? We need to find that one number that would turn the whole group into 0, because this expression will be undefined at that. All right? So let's see. If I subtract 1, I'll get 3x equals negative 1. If I divide by 3, I'll get x equals negative 1/3. Now watch what happens if I put negative 1/3 into that denominator. I would get 7 over 3 times negative 1/3 plus 1, which would be 7 over negative 1 plus positive 1, which would be equal to 7 over 0. And by George, by Jingo, that cannot happen. All right? So you want to be on the lookout that when you start doing this grouping with fractional expressions and equations, oftentimes there will be values for which the expression will be undefined. So you want to keep that in mind. Now, let's take a look here. Here we have 3r plus 5, here we have 3r plus 5, and here we have 3r plus 5. And that's what's really making this problem look so overbearing. But if we think of each of those groups as just x, this would be nothing more than 4x plus 8x plus 1 equals 6x plus 13, which would be a very easy problem to do, right? Okay, so let's think of it in our head like that. If I had 4 x's and I add 8 more x's to that, I would have 12 x's. So I'm going to get 12 quantities of 3r plus 5, and then I'll have this constant right here still. And then over here, I will have 6 quantities of 3r plus 5 plus 13. All right? So I've basically just added like terms here on both sides of the equation. So we're going to take the smaller number and we're going to subtract them from both sides. Okay? And when I do that, if I take 12 3r's plus 5 minus 6 3r's plus 5, I will get 6 quantities of 3r plus 5 plus 1 is equal to, then that will go away when I subtract it, and I will be left with 13. Right now, the next thing we're going to do is subtract 1 from both sides of the equation. And that will leave me with 6 quantities of 3r plus 5 is equal to 12. All right, now the next thing I have to do is divide through on both sides by 6. And when I do that, I will be left with quantity 3r plus 5. But since nothing's going on, I don't really need that parenthesis, since nothing else is going on outside of that quantity. All right, now dividing the 12 by 6, I will get 2. All right, now look, this horrible, ugly thing that we began with is now just a little teeny baby pre-algebra equation. We'll subtract 5 from both sides, and I'll get 3r is equal to negative 3. And then I'll divide through by 3, and I'll get r is equal to negative 1. And I put negative 1 up in here. Each one of these little quantities, if I put a negative 1 in here, negative 1 times 3 is negative 3, plus 5 is 2. Each of those quantities would turn into 2. So let's do a very quick check. I would then get 4 times 2 plus 8 times 2 plus 1 is equal to 6 times 2 plus 13. Well, let's see if that's a true statement. 4 times 2 is 8. 8 times 2 is 16. 8 plus 16, let's see here, 8 plus 16 plus 1, what's that going to be, 25? Let's see what happens over here. This is 12 plus 13, by George, by Jingo. 2 different ways to get it, but on both sides you do get 25. So this little value of r equals negative 1 is the magic number that makes that whole mess true. All right, now this grouping can be used in another kind of real secret little way, right? If you know what a group is equal to. Right, now in this case, I know that this little group, 2x, is equal to 13. Okay? You can use that information in other expressions. For example, let's say you know that 2x is equal to 13, and I ask you to find 4x plus 3. You don't have to do any solving for x or anything like that, because 2x is equal to 13. So what would 4x's be equal to? 26. Yes! Okay? So if 4x's are 26, all you got to do is add the 3 and you get an answer of 29. End of example. Isn't that slick? So there's some number out there that if I square it, I'll get 36. In fact, there's not just one, there's 2 numbers out there that if I square them, I will get 36. What are they? Think of a number, if I take it times itself, I'll get 36.
6 and negative 6?
Yes. So, the solution to this problem is twofold. Either the group is equal to positive 6, or the group, the x plus 5, might be equal to negative 6. All we have to do is add a negative 5 or subtract 5 from both sides of the equation. When I subtract 5 here, I will get x equals 1. And when I subtract 5 here, I will get x equals negative 11. So, these are the 2 solutions. Let's make sure they're correct. If I plug a 1 up in here, I will get 1 plus 5, and when I square that, well, 1 plus 5 is 6, 6 squared is 36. So this one checks. Let's try this one. If I put in a negative 11, negative 11 plus 5 squared, well, let's see, negative 11 plus 5 is negative 6, and if you square negative 6, by George, by Jingo, you get positive 36. So it checks as well.